Hi, I'm Brian Legalio, brand ambassador for Everlast Welders. Today we're going to talk about some titanium. There's a couple things you need to know about titanium. First thing we're going to talk about is fitment. When we get this fit up, we want no gaps, no burrs. It needs to be a square machine cut. If you ever have a burr from the cutting process, you can use a deburring tool like this. Be careful if you are removing material with a deburr tool on titanium. Titanium, you can remove too much too quickly with something like this. So light touch. If you get these nice and squared, no gaps, it's gonna make your welding a lot easier. All right guys, let me show you what I mean. I'm gonna make two welds, one with a pristine fit, and we will offset one just a little bit. And see the difference? I'm wiping these down with acetone. As of now, I will not be touching these with my bare hand, just to, keep oils off of it. That's why we're acetone. We're trying to keep oils off of it. And we're gonna do the same thing with the filler metal. If we can up our chances of a successful weld just by our prep, that helps us out a lot. It becomes a pleasure to weld at that point instead of something that's in a struggle the whole time. All right guys, so I fit this up with a few different scenarios. First one here is, a relatively good fit. This is what we shoot for every time, but sometimes we're left with a gap like this, so we're gonna jump that gap. We're gonna, show you how this kind of goes, and then now right here we have a little bit of high-low. I'll kind of show you some welding techniques to go through each one. Each one, like this one right here, the nice fit up, we're gonna run that with wire and without to show you a couple different methods. Titanium can be ran autogenously without filler metal, long as you don't leave any fish eyes or anything like that and everything's nice and clean. But this guy right here, we're gonna have to add metal because there is a void right there, and I haven't welded titanium in a while. Let's see how this one goes. We're welding off the 210 EXT. This is actually the machine I prefer to weld off of in here whenever I'm in the lab here. But what we have here is we have it on DC. We're set on pedal. Pre-flow, I want 0.2 seconds of pre-flow. The start amps, we put it as low as it'll go. Upslope, we're not using it. 60 amps is where we're gonna be putting the machine. Downslope, we're not using it on this function because we have a pedal. 8 amps as low as it will go. And then post flow, about 10 seconds. And while I'm doing this weld, I'll kick the pedal a few times to reinitiate that post flow. But 10 seconds is a good place to start. Oh, look, would you look at that? I'm gonna start with the wide gap. I don't wanna put any more heat in it and it affect my weld. So I'm gonna start with the widest gap. That's good practice. The bottom's all right. It's not a bad gap, and you can weld that normally until it starts becoming, a little bit more open. It's probably about a 1/16 of an inch opening at the top. The way I'm going, I can feed that puddle. I can feed rod in and dab it in as I'm traveling forward. But once I got to the top, where the gap is at its widest, I'm gonna start having to control the pedal a little bit, do a little bit of pulsing action. I'm gonna have to come off the heat, hit the heat a little bit more, add wire, come off the heat, and so on until I'm to my top tie-in. Next, I'm going to do the one that's fit up well. This one can take a little bit of heat, and because I welded the first one that wouldn't take as much heat, I'm a little shy on the pedal, but I need to add it a little bit more power. But it's going pretty good. And then just keep feeding that pedal. Dab, move forward, dab, move forward. It's just like any other metal at this point. And I'm going to get about halfway up, and I'm going to stop and switch to autogenous. While I'm doing autogenous, I'm pulsating the pedal. I'm puddling it out as my desired width, coming off the pedal, not completely, moving towards the edge of the pedal, repuddling it. So I get the dime look without the heat input. The point of this technique is to keep the heat input down. That autogenous way that you're welding would be strong enough for any application you'd be doing at home for like exhaust or anything like that. it's perfectly acceptable in titanium. Oh, she's a doozy. All right, when I'm on the bottom, the high-low is not so dramatic, so it's not that big of a deal. But as I'm coming around, the high-low starts becoming more dramatic. I'm gonna have to start pointing my heat at the lower plate and filling metal. You can kind of see it almost keyholing on me, kind of opening up. That's no big deal, it's all right. I'm still pointing at that bottom piece of the pie cut. I keep adding filler metal into it and keep moving forward. All right guys, let's compare what they all look like. All right guys, so the middle one where we started had a wide gap in it, and that, you know, lends itself to having a nice lay down bead. I could keep a nice round profile or convex profile by just adding filler metal to it. And, you know, as long as you're controlling your heat, adding filler metal and traveling appropriately, it's achievable. It's not out of the, you know, it's not the end of the world if you have a little bit of gap. This next one here had perfect fitment, and I could have put a little bit more amperage into it. Got it to lay down a little bit more, but, you know, puddled it up, you know, fed a little wire into it as I'm coming around, just dimed it in. Right here is where we started the endogenous. I pulse it all the way up. At that point, it's, you know, pretty easy to weld because the fitment on it is buttered up. It's not going anywhere. It'll take the heat. This one with the high-low, as I went up, the characteristics of it changed. I had to start directing my heat to this lower pie cut than this one. And I don't know if the footage will catch it, but once I kind of directed my heat more here than here, it started coming up really easy for me. I just had to keep that wire filling into it, because as I was coming up, it was kind of doing a little keyhole effect, which again, you have a foot pedal, you have travel speed, you have a wire, all of that stuff is very controllable. You have the tools to do it. All right guys, when you go to weld titanium, all right guys, I always say all right guys, you'll have to keep in mind you have to back purge titanium. We made cymbal caps out of some aluminum foil. This was just a hose we had from another regulator. We have another bottle of argon, but that's not necessary. You can get a Y block. The biggest thing about this is keeping the metal at an elevated temperature in an inert atmosphere. You want to back purge it just like stainless. Very similar things happen. It reacts with the atmosphere at elevated temperature. And actually the colors will tell you what temperature it hit atmosphere. I'd have to pull up the scale to actually tell you. But the idea is to keep it in an inert atmosphere while it is at an elevated temperature so you don't have any adverse effects. There's a reason we're using titanium, just like when we use stainless, there's a reason we're doing it. And when we want to keep those properties intact for the final product. Another thing to keep in mind while welding titanium, this is pretty unique to titanium, is this filler metal gets very, very sticky. My wire's stuck. Come on, little guy. It's all right. We'll get you in there. And it will stick outside your weld zone, and you have to, you know, stop welding and break it off. And it usually doesn't stick to nothing stays on the piece. You just have to break it off. But being precise with adding your filler becomes part of the thing here. You have to be very accurate with your filler. You know, and there is a little bit of leeway if you get close to it and you miss, you just hit in front of your puddle, you can just travel forward and, you know, consume it and pull it back out. But this is very sticky, and only way to ever understand what I'm talking about is actually welding this stuff. And first time you strike an arc on it, first time you start welding on this, you'll see it right away. But keep in mind, filler metal accuracy will come into play with it. All right guys, that's some titanium. I hope this helps you. Do not be afraid of doing it in your own home garage. I'm Brian Legalio, brand ambassador for Everlast Welders. You can follow me on Instagram under Bingo Welding. Weld me and weld green.